Good morning and welcome to another online lesson in Saxon Math Course 3. Now, today's lesson is Lesson 92, Areas of Rectangles with Variable Dimensions and the Products of Binomials, which sometimes is also called binomial expansion. Now, I'm going to be talking about the background and the new format with it all showing. Please just do your best to pay attention, take notes. If you need to take notes on this screen, go ahead and feel free to pause it when I finish talking about it. Don't go ahead and write the notes before I finish talking about it. If you do that, you might write something and not understand what it means. So we're going to jump in with our background information. Now, looking at our background information, we have that you should remember that a mixed number is a number and a fraction. Now, it is usually written as 3 1/2 like this, but remember that 3 1/2 really means 3 plus 1/2. This is important to recognize since we cannot combine a fraction and a whole number. We wouldn't go from 3 plus a half to 4. It's just 3 1/2. Now, this is important to recognize that 3 plus 1/2 is 3 1/2. It's going to come up in a couple of our examples today. Now, during our math lesson, there are going to be two formats we use. We're going to use a rectangle or box method and the FOIL method. There are going to be 4 examples in today's lesson. Now with that, the first 2 examples will be using the rectangle or box method. The second 2 examples, example 3 and example 4, will be using the FOIL method. Please try to pay attention and keep track. Personally, I find that the rectangle method, which gives us a good visual indication that we're done, is helpful. If we can remember the FOIL method is commonly used and is important to be able to know. Alrighty, so I'm going to be jumping into the steps of the rectangle or box method. Now, first off, we're going to be given a pair of binomials or mixed numbers being multiplied. This may be the area of something like a rug, a room, where it's either a mixed number like 3 1/2 or a binomial like x plus 2. Now, please be aware that when we get into the binomials, if it's not all addition, we do need to keep track of that multiplication of negatives rule. If you're having trouble with multiplying negatives and positives, multiplying integers, then check out lesson 36 in your textbook. Read it through again, or go on to Khan Academy. You're going to have more access to a computer nowadays than you would normally in class. Just go to Khan Academy, work on multiplying negative numbers. It's the first section in the lesson in the 7th grade year in Khan Academy. So, we're going to be given a pair of binomials or mixed numbers that are being multiplied. If they are mixed numbers, we're going to write them in the whole number plus fraction form. That's what we showed up here. Then we're going to draw a rectangle and divide each side into 2 sections. Now, this seems like it might be a little bit tricky, but when we get to example 1, it's going to be really clear. We're going to take the rectangle, it's going to have a length and a width. We're going to take the length and we're going to divide it in 2. We're going to take the width and we're going to divide it in 2. Each one of those sections is going to get the number, another section is going to get the fraction. We're going to do the same thing on both sides, and then that's going to create 4 little boxes inside of our rectangle. We're going to find the area of each box by multiplying it by its length and its width, and then we're going to rewrite all of the areas as an addition expression and simplify that. That's the basis of the rectangle or box method. We'll be seeing an example of this with numbers in example 1 and an example of this with binomials in example 2. Now, this next thing that's going to be coming up is important. You will have to be doing this in 8th grade. You will have to be doing this in high school. This is not something you will ever be allowed to forget. So, commit this to memory. The FOIL method. Now, FOIL stands for first, outside, inside, last. Now, I'm going to show you guys what I mean by that. There are 2 binomials right here, x plus 1, x plus 2. Step 1 is you're going to be given a pair of binomials which are multiplying. That's what we got here. You can see that they have a parentheses around them. Inside of those parentheses, we got some binomials. There's no operation in between the parentheses, which means that this is multiplying. Now, step 2 is you're going to multiply the first term in each binomial. Now, I color-coded this so you guys can keep track of it a little bit easier. The first term I underlined in red. It's the first one in each set of parentheses. Notice in this set, the first term is the x. In this set, the first term is the x. So we did x times x. And I know all of you know that x times x is x squared. The third step is to multiply the outside terms. And now, when we go from first to outside, first talks about the first term in each binomial. Now, that means that we went to the first term here and the first term here. The outside terms are the terms that are on the outside of the expression. So we have x over here on the outside, on the far left side. We have 2 on the far right side. So we're going to have x times 2, which is equal to 2x. And then our next step is the inside. The inside is the opposite of the outside. The inside of the numbers right here. The 1, the x. So we're going to multiply 1 times x and get 1x. That means we've multiplied the inside term. And now the last step is to multiply the last term in each binomial. Now the last term in this first binomial is 1. The last term in this second binomial is 2. So we're going to do 1 times 2, which is 2. Now there is one small step, and it's very similar to step 5 of the box or rectangle method. And that is that we're going to rewrite all of the areas as addition and then simplify. So here we would take x squared plus 2x plus 1x plus 2. Notice all of these terms are positive. Since all of these terms are positive, we're going to add all of them. If any of them were negative, they would keep their negativity and have a subtraction sign in front of them. So we're going to add them all up, and notice these two terms in the middle, the 2x plus the 1x, these are like terms. Because they both have an x, we can add them, and 2x plus 1x, well, that's just 3 x's. Now, I've gone through each of the steps in the method. I'm going to zoom out a little bit. And now, at this time, if you'd like to pause the video, I'm going to give it a little bit of a focus, just like we do in class. If you want to pause the video, do so now. Get these notes into your notebook. Alright, so we've got our notes in our notebook for our new format. Now we're going to have to get started on examples. Now example 1 says that if we have a 2.5 foot by 4.25 foot rug, we can find the area by multiplying 2 plus 1/2 times 4 plus 1/4, and that, we'll notice, satisfies step 1 and step 2 of the rectangle method. Now we've got our two set of almost binomials, but are mixed numbers written in whole number plus fraction form. So now our next step is to first sketch the rectangle on a grid. Now notice I've already gone ahead and sketched this for you, and I've started doing our multiplication for areas. I haven't finished anything out, but we can see how we're going to do this. Now, in order to find the area of the whole rectangle, we would need to add up the area of each of these little rectangles. Now, this is an area that's 2 by 1/2, 2 and 1/2 by 4 and 1/4. You can see that I've just made 4 and then added on a quarter, 2 and added on a half. Now, to find the area of this big box right here, it's pretty simple. It's 2 by 4, because this 2 is the width and this 4 is the length. So 2 times 4 is 8. Now here we have a rectangle that's 1/2 as its width and 4 as its length. So our area for this box is half of 4. Half of 4 is 2. This one's a little bit trickier. 1/4 of 2 would give us 2/4, or 1/2. 1/4 times 1/2 is going to give us 1 times 1, which is 1, over 4 times 2, which is 8. So now we just take each of these 4 areas and we add them. So we have 8 plus 2 plus 1/2 plus 1/8. Alright, now 8 plus 2, that's going to be 10. 1/2 doesn't have a common denominator with anything else, so we're going to write plus 1/2. And 1/8 is going to be plus 1/8. Now, in order to add these, we can change a half to an eighth. Remember that if we multiply the top and the bottom by the same thing, in this case it's going to be 4 over 4, we're going to get 1 times 4 over 8. Now, in that case, we can do 4/8 plus 1/8, which is this section here, which would give us 4 plus 1, which is 5/8. Now, 10 and 5/8 will give us a mixed number of 10 and 5/8. Now, we're given a unit of feet, so this would be square feet. Alright, that's example 1. Now, working through it, we were given our two mixed numbers multiplying, written as a whole number plus a fraction. So we've got our two mixed numbers. We have put those on a rectangle. We multiplied out each box to find the areas, and then we just add them on up. Alright, now moving on to example 2. Now example 2 says a rectangle is x plus 3 units long and x plus 2 units wide. What is the area of the rectangle? Now notice here, I have x and I have 3, and I did not keep the plus. That's because this 3 I'm saying is positive. It's positive because of the plus. This 2 is positive because of the plus. If this was x minus 2, we would have x and negative 2. If this was x minus 3, we'd have x and negative 3. But it is a plus 3 and a plus 2, so we have x and a positive 3, x and a positive 2. In order to find the area of each box here, all we have to do is take the width and the length, x and x in this case, and we have x times x. Here we're going to have 2 and x, so 2 times x. Here we're going to have x and 3, so we're going to have 3 times x. And here we're going to have 2 and 3, so we're going to have 2 times 3. X and x multiply to be x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. You may think to yourself, I'm done. You're not done. You have like terms right here in the 3x and the 2x. They both have an x, neither x has an exponent, and there are no other variables in each term. They are not like terms with the x squared, however, because the x squared has an exponent of 2, which makes it different from the x and the x in 3x and 2x. So we're going to write x squared. And then we have to ask ourselves, if we have 3x plus 2x, how many x do we have? Well, 3 plus 2 is 5, so it's going to be 5x. Now, last but not least, we have our number here, this plus 6. It has no x, and there are no other constants in this expression, so we can just write 6 as a number right here. So we have x squared plus 5x plus 6. Now, in this case, we do not have any common terms, no like terms here, so we are done. This is the end, and we stop. Take a second, make sure this is in your notes, pause the video if you need to, and then we're going to move on to examples 3 and 4, where we're using the FOIL method. Alright, so this example is going to look a little bit more colorful. I find that using color coding when we're starting to learn these steps will help us cement it in our memory. Because remember, this FOIL, this first, outside, inside, last, is going to come up again and again and again throughout your education. You will need to know this for every math class you take from now until college, except for, well, actually, in most math classes. You're going to be expanding binomials, multiplying binomials, in almost any math class you take. So, to get started, we're asked to expand x plus 3 times x plus 2. Using FOIL, we first go to our first term. Now I've underlined it in the problem, and you should see that our first term in our first binomial is x. Our first term in our second binomial is x. So we're going to have x times x. On the outside terms, remember, are your far left, your far right. From the first binomial, the far left is x. The far right from the second binomial is 2. As we're moving forward to the inside, remember, are your center numbers, the ones that are almost looking like they're together already. The 3 and the x. We're going to have 3 times x. And last but not least are the last numbers. The last numbers, remember, similar to the first ones, are the ones which come last in each binomial. In this first binomial, it's x and then 3, so we're going to have the positive 3. And then we have x and then 2, so the positive 2. Now, when we multiply these, we should see that we're going to have x times x, which is x squared. We're going to have x times 2, which is 2x. We're going to have 3 times x, which is 3x. And we're going to have 3 times 2, which is 6. Now, as we're going through this, we should see this is not done. We have a set of like terms. In fact, it's the same set of like terms from the previous problem, because this is the same multiplication as the previous problem. We have the same binomials. We're going to be getting the same answer of x squared plus 5x plus 6. Now you may be asking yourself at this point, Mr. O, why did we do the same problem twice? And I'll tell you, we did the same problem twice so you can see that these are two methods used to solve the same exact kind of problem. These are not different from each other. In fact, the box method, or the rectangle method, is actually just a graphic organizer for using the FOIL method. If we go back to our box over here, we can see that this was our box x times x. That was the first term in each of our two problems. We can see that we have our first, our outside of 2 times x, our inside of 3 times x, and our last of 2 times 3. And you may ask yourself, why would I need to know 2 ways of doing the exact same problem? And the simple answer is the box method may take up a little bit more space on your paper, but if you can remember that we set up the boxes and find the areas of them, it's a little bit easier to memorize. The FOIL method is a little bit less room on your paper, but takes up a little bit more space in your brain. It's a little bit harder to memorize the FOIL method than the box method, but if we can remember that first, outside, inside, last, then we can get these problems done just as easily. Now, if I was in class, I'd ask you to repeat after me, first, outside, inside, last. I might call on people saying, what's the F? First. What's the O? Outside. What's the I? Inside. What's the L? Last. Unfortunately, since we're in an online learning environment, I'm going to just ask you, please, repeat after me, first, outside, inside, last. And make sure, if you're unsure, that you practice doing these problems. We're going to see a whole lot of examples of these in the practice set. I'm going to be putting out a video later today with the practice set for these problems. If you're lucky, I'll also do one with the starred problems for your homework. But we're going to move on to example 4. Now, example 4 asks us to expand using FOIL. Now, our first thing that we do, first things first, we get the first term in each binomial. Now, the first term in our first binomial is x. The first term in the second binomial is x. And notice we've got x times x. Now, our outside terms are x and negative 4. So we're going to have x here, but it's important that we keep the minus with the 4. The inside term is going to be minus 3 and x. So we're going to have negative 3, which we've got to keep the negative with a 3, and x. The last terms are going to be negative 3 and negative 4. One of the things you should notice, I'm underlining each term in the problem as I'm going, and each term has exactly 2 underlines underneath it, because we use each term exactly twice because they are binomials. Now, as we're going through, x times x is x squared. X times 4 would be 4x, and it would be plus 4x, but it's x times negative 4, so it's going to be 4x, and since it's negative, we're going to have a minus. For our inside, we have negative 3 times x, so we're going to have a 3x, which is being subtracted. Now, the last one's a little bit trickier. We have negative 3 times negative 4. I know you all know that 3 times 4 is 12, but a negative times a negative, is that a negative or a positive? I want you to think to yourself, tell the video the answer. I'm going to wait a few more seconds to make sure everyone's told me the answer before I tell you that, in fact, it is a positive. Remember, if the signs of a multiplication problem are the same, it will be addition, or a positive answer. So, we will have x squared, and now these are both like terms of x and x. Negative 4x and negative 3x together make negative 7x, and then we'll still have plus 12. So that's x squared minus 7x plus 12. And that's our last example for today. I hope that you're all doing well. I hope you're all doing your homework. I've seen a couple of people already turning in lesson 91. Make sure that when you're done watching this video, finish up taking any notes. If you need to go back, re-watch any sections, see what I've done, please go ahead and watch those. If you have any questions, make sure you leave a private comment for me on the assignment in Google Classrooms. Have a wonderful day, stay safe, don't go to any crowded places, and be healthy.